Okay, so hi everyone, I'm Kelvin. Yeah, happy to be here. So today I will be presenting my first phase efficiency solution. It will be a very simple solution. I guess everyone already know. Okay, so agenda will be covering some background summary, feature selection and engineering, training methods, important findings, and yeah, finally it's just a simple model. So for background, yeah, I'm a data scientist at H2O, like Guangzhou. So for my success in this competition will be mostly my domain knowledge for my task commonly and feedback price related competition. And for summary, basically I use two data sets. One is the pursuit corpus, yeah, and the second is basically I use an additional education data set from Kids Frontier. So what is Kids Frontier data set? So basically this is basically it contains articles written by scientists and they are reviewed by a broad range of young people. So young people, they came from grade 1 to grade 13, or basically these students have to read the article to make sure they actually understood the content before this article will actually publish. So I actually utilized ChatGPT 3.5 to generate a summarization of this Kids Frontier article. So has an external data set. So of course, for the feature engineering, I'm using the training a custom bytecode encoding tokenizer. So these are basically trained on the test data set to generate a vocabulary that will be used to speak on our training data set. Yeah, so finally, it's just a simple machine learning classifier on top of the TF-IDF features. Okay, so for feature engineering, I actually take inspiration from this notebook. So this actually is a great notebook that allows us to train a very simple custom tokenizer that performs pretty well because it allows us to tap into the vocabulary of the test data set so that we don't have to actually guess what is the features that we have to include in our modeling. Okay, so yeah, this is just a simple bytecode encoding. So we have a custom bytecode encoding tokenizer. So this was actually trained on only the test data. So this is like clicking into the test, but of course we are only using the vocabulary. So we are actually not learning on the test data. Yeah. So for the train tokens, of course, definitely we have to generate a train token. So these train tokens were generated from my train plus external data set. So this including the original DIGT dataset and also my pursuit plus and Kids Frontier. So this is generated using the learn by pair encoding tokenizer, which was learned only from the test data. Yeah. So of course that token was also generated because we have to run inference at a later stage. So for TF-IDF, there's two vectorizer. The first one is basically to generate a test vocabulary of the features with the word and green range 3 to 5. So this was actually run using the learn bytecode encoding tokenizer, and of course using the test token has the features for the first vector TF-IDF, and the second is more of actually generating the actual TF-IDF features of the bytecode encoding train tokens. Yeah, of course using the same parameter, the same n-gram range, and this is of course this TF-IDF was using just the vocabulary from our first TF-IDF, which was actually like learned from our bytecode encoding tokenizer from just the test data itself. Okay. So for training methods for dataset, I use the pursuit corpus 25K samples, and additionally I also generated 60K samples from Kids Frontier. So originally for Kids Frontier, I created around 600 samples, but of course from these 600 samples, I generated 60K. But of course, for the final training, I'm only using 30K samples, but it's more of like the efficiency kind of approach that I'm going to use because I'm actually training on the public leaderboard. And the features, yeah, it's basically just TF-IDF features with word n-gram range 3 to 5. And the models I use is 3 simple ML classifier, the multinomial naive base, and SGD classifier, and also some like BGN classifier. So an example, basically, I just take every of this model has a base classifier and just assign them a weight. Yeah. So the final summation time, including both training and inference, is 70 minutes, and the public LB is like 0.947, and the private LB is 0.91, which is quite surprising because I'm not expecting this solution to be a first-based solution, given the public LB is only 0.947. Okay, so some important and interesting findings. So yeah, like I shared earlier, actually I took part in many of the commonly and feedback prize related competition. So somehow I have some idea of how to model the data, because data is a key, especially in this competition. So actually I focus more of my effort on creating a very good data set for this competition rather than doing extensive modeling, of course, due to some other constraint I have, like maybe not having enough resources like GPU. Yeah. So for this, actually, I use the Kids Frontier data set. So you can see on the right, this is like a example of the article that we can actually access from Kids Frontier. So it's a very long journal written by scientists. So you can see like this is the extract, some of the contents of what is this article talking about. So my idea was actually, yeah, just to call it a good educational data sets. And after that, the actual solution I find that it helps me a lot is actually to come up with creative prompt that allow me to generate the data set that is similar to, not really similar to the distribution. It's more towards how students actually write essay. So my first prompt is like, given the following text, what are some questions to ask? So, and generate at least 40 different questions. So let's say this prompt will actually take this article as a text and it will generate 40 different questions from these articles. Yeah, so this is all done using ChatGPT 2.5. So my second prompt is basically second level prompting. Is like, given the following article, which is the same article, summarize the question, which is the one of the 40 questions that I generated, has a grade level grade student. So grade level, actually I have like between 1 to 13. So it can be anywhere between 1 to 13 grade level student. So this prompt will generate a summarization of this article. Using this question has the context in less than 500 words. So the summarization can be either complete, incomplete, or partially complete. So actually the last sentence is very important here. We don't want the generated summary to be very complete and professional. So sometimes it might stop halfway, or maybe it will generate some just like a 2-paragraph summarization. So I find this actually helps a lot, like this last sentence. And of course, the article here is basically just this article here. Yeah. So for the model training, it's just a simple model because I'm more focusing on the efficiency solution. So it's just 3 simple models which I described earlier: multinomial naive Bayes, HED classifier, and LGPM classifier. And the example basically just taking 3 of them and assign them a weight. Yeah. And the final training time is 70 minutes. And this is the final score. The public LV is 0.94, which wasn't great. And the private LV is 0.91 for the efficiency leaderboard. Yeah, I think that's